This lesson is about B7, springs. From Hooke's law, we know that the force on a spring is directly proportional to the extension of that spring. If we have a spring of original length L and we apply a force by perhaps suspending a weight from it, then the spring will be extended. If we apply double the weight, then the spring will be extended twice as far, and 4 times the weight will extend the spring 4 times as far. The two are directly proportional. The spring constant, which indicates how stiff a spring is K in this formula, and it is equal to the force that is extending the spring divided by the extension of the spring. Its units are usually newtons per metre or newtons per centimetre. The original length of the spring is sometimes called the natural length of the spring, and Hooke's law is obeyed up until the point where the spring becomes permanently deformed. If we take 2 identical springs and connect them together in series like this, then the natural length is longer. When 1 newton of force is added, each of those springs is extended by that 1 newton of force, and therefore each of those springs is extended. The overall extension is now going to be twice as big as it was before, even though we have the same force. If we examine the equation at the top, if we have the same force but get double the extension, that must mean the spring constant is effectively halved by placing 2 springs in series, if the 2 springs are identical. In fact, when you combine springs in series, you can add the spring constants like this. It's very similar to when you combine resistors in parallel. And so you can make use of the reciprocal key on your calculator and say that the total combined spring constant is equal to the reciprocal of the sum of the reciprocals of the spring constants. If I have 2 identical springs in parallel and I apply a load, then they share that load. So in the case drawn here, these are 2 identical springs. Each of them has half a newton extending it, and so each of them is extended by half as much as if a single spring were extended with a force of 1 newton. Treating these 2 as a single body, that means that for a given force we have half the extension, and so to halve the extension means to double the spring constant, or double the stiffness. More generally, if you want to find the combined spring constant for springs in parallel, you simply sum each of the spring constants.